So in the last lesson, we ended up with something like this, where we dealt with the recursive function. Now, recursion allows us to call the function from inside itself and essentially modify some of the arguments on the way in. In our case, we took the numbers that we were passing in, checking if they were greater than 1, and then multiplying it by itself minus 1, which then kicks the whole thing off again, and we go through the same check all the way down to whether the number equals 1 or not, and then we multiply that last result by 1 to obtain our numbers. So in this lesson, what I want to do is discuss the concept of memoization. Not memorization, but memoization, which is more of a computer sciencey topic and will creep up again and again with functional programming talk. So what is memoization? Essentially, it's a way for us to cache the results of a function call, assuming it is a very heavy function call. Now, what do we mean by heavy? So for example, at the moment, we've got 3, 6, and 9. If we were to calculate our factorial of 9, we would of course expect JavaScript to go and calculate it for us. With 6, we'd expect it to go and calculate as well. However, with 9, again, it seems a bit pointless and it's going to use up a ton of resources, assuming that it's a much more heavy operation than this. And this is why we're demonstrating things in a simple scenario so you can see how they scale and apply to bigger code bases. Now, what we are in fact going to do is create a memoize function, and we're going to then create an internal cache. Understanding our closure knowledge, we're going to return a function which is then going to check if the result is in the cache. Otherwise, we're going to calculate it. If it is in the cache, we'll then go and grab it back. So let's kick off our arrow function. What I'm going to do inside is create our quick return statement where we're going to grab a few args, and inside the body of the function, we're then going to check out what this args object is, as well as checking out this function. Now, for us to memoize our function and also look at the arguments, we need to now memoize our factorial function. The easiest way to do this and to explain the memoization and make sure that you understand all this is we're just going to build it and explain it as we go. Now, typically when we're using a JavaScript library or a framework, or it doesn't matter what, you won't have to write this memoize function yourself. However, I am going to explain it piece by piece as we assemble and also uncover the meaning and the use cases for memoization. So let's carry on and we'll do memoized factorial. What we're going to do is use our memoize function, and we're going to simply pass in our factorial function as well. So this will in fact give us back a memoized factorial version, which is then going to cache the results. So each time we don't need to go and grab something new if it's already been found. So what we can do is replace our factorial calls with our new memoize calls. Now this of course is going to break everything. So we're not expecting to see our factorial results just yet. We're looking at just the function and the arguments. Now, what's interesting is the function that we're logging is in fact our factorial function that we've just passed into memoize. So when we call the first closure, our function is essentially cached in this scope here. It doesn't go anywhere until our program is destroyed. Now, because it returns us another function which has access to this closure, this function can then be in charge of calling our initial function. However, what we're going to do is cache the results of it, and inside we're going to check whether we've already calculated, for example, our memoized factorial of 9, because it would be much more efficient to just calculate it once if we've already done so. So that's the theory behind it. What I'm going to do is create a cache object. Now what we're going to do, because it's a constant, we can add properties to it. Now that we've looked at the function, we've also got the arguments. You can see 9, 6, and 9. So that's crystal clear. We get what's going on now. So what we in fact want to do is check if something is in our cache. So what we're going to do is create a key. Otherwise, we can't create our cache to begin with. Now the key is going to in fact be our args. However, what I'm going to use is JSON stringify. By stringifying it, we'll take a look in a moment. It will allow us to create a unique key based off of each function argument and then cache it on the object. So first things first, let's have a look at this key, and I'll also log out our cache object. Now to stop any errors, I'll also log out the function, but we can just ignore that. So here we have our key, and you'll notice that the text is black. It was blue a moment ago because it was an actual array, whereas now it's a string with the number 9 inside, which has been stringified. We then have the cache, the empty object, which we can then go and add some properties to. So if we were to say cache, square brackets, and key equals, we could say 1, 2, 3, hit save, and then we have this object, which now has a number 6 as a key, 1, 2, 3, 1, 2, 3, and the number 9. You can see that by adding 9, we are creating a property, and then when we call the second 9, it's then going to override that property. If we were to change this to a 5, for example, we'd have 9, 6, and 5, respectively. Now, the interesting piece is we don't want 9, 6, and 5. This 1, 2, 3 needs to be a dynamic value. So to get a dynamic value, we need to obviously call our function. So we're going to say function.apply. We can pass in null because we don't want to set a this context. And then we're just going to pass in that args array. Because we're using apply expects an array as the second argument, so we don't need to do anything there. But let's save this out and have a look at what we get. So you can see here that we have our 720 and 362,880. So they are the results of calling our factorial function, and we're doing so after the function has been returned each time. So we're essentially hijacking and intercepting the function call and then caching it via our internal object, which is maintained in our closure when we first memoize the function. So this is really nice, and we've got our key, we've got our cache, and we've got the function. However, what we need to do now is in fact check if it's in the cache. So we can say if the key in the cache, then we know completely that we have already set it. So at this point we can say console log, and we can put getting from cache ... and we can simply return the cache, square bracket, and key. Now, because we are returning, we don't need an else statement. We can simply just say console log, and we're going to use caching ... So let's save this out and see what we get. We have undefined because we need to return our cache key. So let's update that. So now we have our caching. We also have our getting from the cache because we have a cached result. We've seen the key in the cache has already been called. So this is really nice. This is a pretty bulletproof solution because what you can in fact do is have multiple function arguments that also do the same thing. So for example, we could have 9,99, and we could also have 9,9,9. If we were to just simply join the string, this would be an argument which is cached as just 999. So that's actually why we are using JSON stringify. And I'll just quickly demonstrate this because we can open up the key and just check what it's giving us. So here you can see that by using JSON stringify, it actually will persist the comma separated arguments. Now we could in fact say something like this, and we could do args.join, and we would have to join it with a unique character such as a pipe, or you could use a comma yourself. Have a play with that and see what you think. Have a mess around with it and get familiar. One good thing about using JSON stringify is it actually persists things such as objects. So instead of using this, we could say that we have some kind of object and we're going to put our name. Similarly, we can copy the function just to make it the exact same. And you can see that when we have numbers and data structures, we're actually creating a property on our cache. So the key is in fact this, which I've highlighted here. And you can see that it works absolutely perfectly because we are using JSON stringify. Now, if we were to supply a function, JSON stringify will turn this into the value of null because you cannot stringify a JavaScript function. So keep that in mind. But essentially what we've done is look at memoization. We've created our own memoize function that accepts the function that we want to memoize. We then return a closure. We can intercept the arguments. If something is in our cache, then we can return it. Otherwise, we're going to set that particular item in the cache by applying the arguments that we took from the closure, from the function, and applying them to our initial memoized function, the factorial. So all it is a small wrapper around the function that we pass in, and you can memoize any kind of function that you like. providing that it actually works with memoization and makes sense to. The only rule is the function arguments will need to be the same, so when we call the function again, we know that the value will be fetched from the cache. Now what I like to do, of course, is use more of a lambda expression. So what I'm going to do is just change these over. We're going to make this a nice one-liner to finish off this video. So we don't need any of this. We can tidy things up quite substantially. We're going to hit save, and you can see that we have a fully working Memoize implementation, which also works dynamically with different function arguments. And this is known as a multi-slot memoization. If, for example, we just had a function call with no arguments, perhaps, we could in fact memoize it as is, but that only gets us so far. So typically what we would do is memoize a function with its arguments, because that makes a bit more sense. So I hope you liked the video. I think memoization is a great topic for us to deal with, and this is for resource-heavy calculations, maths. It could be traversing nodes of particular data structures, you name it. If it's a heavy operation, it might be a good idea to memoize the result. Not just by including a random function from a library and just hoping that it will go ahead and memorize our work for us. We've actually created and understood our own Memoize implementation, and I think that's a really powerful thing for us to learn. So that's it for this video. I hope you enjoyed learning about recursion and memoization and how we can achieve more performant JavaScript.